Okay, everyone. Today is another review. We're just doing graphing linear equations today. I know the slide says in systems of equations, but we're just doing graphing today. So we're going to get started. We talked about yesterday or Friday the three forms of linear equations. Just want to go over those again. We have standard form is ax plus by equals c. Your slope-intercept form, again, was y equals mx plus b, and then point slope was y minus y1 equals m times x minus x1. We're going to be using some of these as we kind of do our work today. Mostly what we're going to be doing, though, is graphing lines. So just want to kind of take a look and see how we're going to work through this. Okay, so graphing linear equations. We're going to start. There are a bunch of different ways to do it. We can graph linear equations from every type of equation, but we can also do it from 2 points. So here we are, we're given 2 points, 3, 2, and 4, 6, negative 4, 6. We're going to follow the steps. We'll put the steps in, and then we're going to graph the points and see what the line looks like. So your first step is to plot each point, or plot points at each ordered pair. So we're going to put a point at point 3, 2. We're going to put another point at negative 4, 6. And then the second step is just connect the dots. We're always trying to plot 2 points and then connecting the dots with a line. So that's what it would look like if we were graphing by 2 points. I'm sure it makes sense. I'm sure everybody kind of has done this before and knows what we're working with. Second is from slope-intercept form. Now here we are, we're given an equation of a line in slope-intercept form, the y equals mx plus b form. Our first step with this is always to plot a point on the y-axis where the intercept shows, so the b number. In our instance here, b is negative 9, so we're going to go down to negative 9. Remember, the negative sign or the positive sign tells you what side of the y-axis to go to plot your point. So here we have our point at negative 9. Our second step is to move to a second point from that original point. So we're going to go from the intercept point that we graphed based on our slope. And our slope in this instance is up 5 and to the right 1 because it's just 5. We always remember it's 5 over 1. We're always moving up or down the top number of our fraction and then to the right, the bottom number. So here we're going to go up 5 points, one spot to the right. It's going to give us a point at 1, negative 4. Again, our third step is just connect the points with a straight line. So there we go. Does that make sense? Everybody kind of sees that? We're all good with this? Homework tonight is just going to be lots of graphing lines and stuff. So we're going to make sure we're all cool with graphing lines. All right, second one is graphing from point slope form. Now we have our equation of our line. Y minus 7 equals negative 2/3 times x plus 6. Remember in a point slope form, the general form is y minus y1 and then x minus x1. So in our example here, we have a negative 7, so our y value for our point here is going to be positive. It's going to be 7. The point for 6, though, for our x value, that's plus 6 in our equation, so that means we're actually looking at negative 6. So again, our first step is to plot the point at our ordered pair. So we've already decided our point is negative 6, 7. So we put our point at that point. Our next, again, is to move from that point based on our slope. So our slope here is negative 2 over 3. So our first move is down 2. It's minus 2. Then it's going to be the right 3 points. So it's minus 2 over the right 3. We have our second point. Our last step, as always, is to connect the points with a straight line. And there we are. Does that make sense to everyone? Just have to remember that the form of the equation is y minus y1 equals m times x minus x1. So if you see a plus in those equations, we're looking at the opposite for our point on the graph. Okay, from standard form, again, this is a little bit trickier. It's still pretty easy, but it's a little bit trickier in terms of trying to find what we want to do and how we're going to graph it. What we do in these is we graph what we call the intercepts. We can create an x-intercept and a y-intercept, you'll see in the steps, to plot points to create our line. So our first step is to plot the x-intercept. We do that by plugging 0 into our equation for y, and then we just solve that equation for x. So if we plug 0 in for y in our equation, we're going to have 4x minus 10 times 0 equals 20. 10 times 0 then goes away. It just becomes 4 equals 20. Again, there we're just going to solve for x, so we're going to divide both sides of our equation by 4, and we end up with x equals 5. So our point there then is 5, 0, because we plug 0 in for our y value. Does that make sense to everyone? Everybody see that? Okay. Our second step is to plot the y-intercept. It's the same thing. We're going to plug 0 in this time for x and then solve for y. So if we plug 0 in for x, we're going to end up with 4 times 0 minus 10y equals 20. So we're going to be left with negative 10y equals 20. Again, we're going to divide both sides by negative 10, which is going to leave us y equals negative 2. So we're going to plot a point at 0, negative 2, because our 0 was in for x. So our point is 0, negative 2. Does that make sense to everyone? Okay. So our next step is to connect the dots with a straight line. And there we go with our graph. Everybody cool with this? Everybody understand what we're trying to do standard form wise? Again, we're going to need the graph standard form equations just through our section on solving systems of equations, but we really won't do a lot of that graphing in geometry. Okay, moving on. Here's 4 problems for you to try. There's 1 of each equation, so kind of go through. You can look back at the notes. You can kind of go back on the video if you're not quite sure how to do them again. Or you can look at the note sheet that I've posted out there for you. But again, plot these lines, come back and check your work, and we will see how you have done. Okay, so you're finished. We plot all the 4 points on the same graph. I color-coded them, so the red is the first one. A, we plotted our 2 points, 10, negative 9, 5, negative 8, connected them. B was the standard form equation, excuse me. So we solved each value for x or y, plugging in y, x0 for the other value. So we plugged in 0 for x. For x, we found out that our y value was negative 3. If we plug in 0 for y, we found out x was negative 6. So we have those points. Again, we connect the dots. The third one was the light blue color. Y equals 4 over 7x minus 3. Again, our y-intercept ends up being the same intercept as the equation before that, so that's why you only see one dot at that negative 3 point. I tried to make it look like you could see the purple one too. And then from there, we go up 4 spots for our slope. To the right, 7. So we have our point at 1, 7 there, and then we connect the dots there. And then last, the green line, y plus 3 equals 5 times x plus negative 4. So the first point we're going to graph is plus 3 minus plus 4. That makes it a negative 4 for our x value and negative 3 for the y value. So we go on and we plot that point. Our slope is up 5 to the right 1. So we go up to that. We go up 5 points to the right 1 point. And we draw our line in. Did everybody get those? Does that make sense to everyone? Okay. Parallel lines. I want to talk about those for a minute because we do have to deal with parallel lines and perpendicular lines in geometry, but there's a different geometry definition than there is algebra. So the geometry definition for parallel lines, which we'll learn again as we get into it, is 2 lines drawn into infinity that will never intersect. Think of the yellow dot, the dividing line in the highway, the yellow line down the middle of a road. Those are never going to intersect. If we assume the road goes on forever, they will never intersect. The algebra definition, though, is completely different, but it does mean the same thing. The algebra definition is 2 lines that have the exact same slope, but different y-intercepts. So having the same slope, if you think of it on a graph, they have the same slopes, so they go on forever. They'll never cross in our graph, but they're just going to cross the x-axis in different spots. So we're going to graph 2 lines showing, take a few minutes, try it yourself, graph the 2 lines and see what they look like, and then come back and kind of check what I did on my side. Okay, so here's the red one is the first one. I kind of highlighted the red dot next to that one. There's our red line. Y-intercept is negative 6. We come in with the blue line. This is our second line. Again, that's going to go that way. And they're never going to cross. They're going to go on forever and never cross. Okay, so here's one for, here's something for you to try. Actually, we'll go through Excuse me about that. Sorry about that. We'll go through our example here together, and then I think there's one for you to work after it. So like I say, in algebra, you're going to be asked to find a line parallel to some given line that goes through a specific point. So in our example here, we are told find the equation of a line parallel to y equals 3x plus 9 that passes through the point -1, -4. So when we think about parallel, remember, we need to have the same slope. So we're just going to pull the 3 from our original equation there. So the slope must be 3. Again, I talked about on Friday, we don't have a specific form to use. They're just saying find the equation of a line. So I'm going to use the easiest one I can have with the information I'm given. And this one, I don't want to have to find what the y-intercept is because they don't give it to me. So what I'm just going to do is I'm going to use point slope formula, or point slope form. And I'm going to plug in my slope of 3. My x and y value and my point that I go through are both negative. So I need to remember there when I write the equation down, I have to flip the signs in the equation. So it becomes y plus 4 equals 3 times x plus 1. Did that make sense? Did everybody see what we were trying to do there? We got the line. We didn't grab anything, we just got the line. Okay, here's one for you to try. In this one, though, I do ask you to give me the slope-intercept form. I've given you the equation and y-intercept, or point slope. So you'll do have to do some math to kind of sort it out. Work it through, and then come back and check your work. Okay, so we're going to start with the point from our original equation. It's 5. So our new line has to have a slope of 5. I've asked you to create the slope-intercept form, but we're going to start with point slope form to get there because we're able to solve point slope form for y to get to the slope-intercept form. So we plug 5 into our equation, we plug our points in, and we get the point slope form to start with is going to be y plus 7 equals 5 times x minus 4. We're solving for y, so we distribute 5 through. Y plus 7 equals 5x minus 20. We subtract 7 from both sides. You'll end up with an equation of y equals 5x minus 27 is going to be parallel to that original equation. Does that make sense? Awesome. Okay, here's another one for you to try. This time, you're going to have to figure out the slope. I didn't give you the slope in the equation, so I'm going to make you figure it out. Again, work through it, come back and check all your answers and see how you did. Okay, so you should be finished. Here are the answers. They're going to kind of pop up as we go through. We'll talk about them as they come up. They're going to get a little ahead of me, but we'll talk about them as they go. So we had to find the slope, so we used our slope formula. We found out that the slope was 3. Our points were y2 minus y1 over x2 minus x1. I did the biggest points first. So the slope was 3. So I know my slope. I knew what slope was, so I got to plug into the equation. I recognized that they were looking for either form. It didn't matter which form they wanted, but I recognized the point they gave me that I go through was actually a y-intercept point. 0, 10 is a y-intercept point. So I can just go right to slope-intercept form and have y equals 3x plus 10. That make sense? If you got point slope form, that's fine. You would probably have y minus 10 equals 3 times x plus 0, or y minus 10 equals 3x. Either way works, but if you recognize point, the intercept there, the point they gave us, good on you. All right, moving on. Perpendicular lines. Again, we're going to do a lot of work with perpendicular lines in geometry with some of the stuff we're going to do. It's going to be very important to determine triangles and stuff, but we're going to talk about them in terms of the geometric definition and then the algebra definition for today. So the geometry definition of perpendicular lines are 2 lines that intersect at a 90-degree angle. There's really no way in geometry to tell other than a little box that they put in the corner where the lines intersect. We'll talk about that when we get there, probably in about a month. The algebra definition are 2 lines that have slopes that are opposite reciprocals of each other. Do you remember from earlier math what the opposite reciprocal is? If you don't, that's okay, but if you do, awesome. Opposite reciprocals are We flip the numerator and the denominator of our slope or a fraction. Reciprocal of a fraction is just flipping the numerator and the denominator. When they want opposite reciprocal, we're talking about the sign. If our slope starts off as positive, the opposite reciprocal is going to be negative and then flip the slope. So if we start off with positive 3 over 4 for our slope, so 3/4 is our slope, the opposite reciprocal of that is going to be negative 4 over 3. We flip the fraction and change the sign. Okay, so again, take a few seconds, try to graph these lines, see what they look like when you finish. Notice that the slopes are 3 over 2 and then negative 2 over 3, so they're opposite reciprocals. So they should end up being perpendicular, looking as perpendicular as they possibly can as you graph them. Okay, so same thing, we have a red line and a blue line coming in, showing you what we did. There we go. Sorry about that. The screen froze. So the lines, we can't completely tell, but if where our slopes are opposite reciprocals, I know that those two lines form 490-degree angles there, which become very important when we start working in geometry a little later on. Is it making sense to everyone? Okay, moving on. Again, we have an example. We're asked to find a line perpendicular to some given line that we're given. Not specified, so we have to figure out what the slope's going to be. We see that our equation was y equals 3x plus 9. So we're going to flip that. Remember, it's 3 over 1. So to flip it to the opposite reciprocal, we're going to have negative 1 over 3. We weren't specified an equation, so we're going to use point slope because I don't have an intercept readily available, readily identifiable, so I can do the point slope form. Again, my point was negative 1, negative 4, so they're in point slope. They'll end up being plus 4 and plus 1 on the x and y side. So our equation ends up y plus 4 equals negative 1/3 times x plus 1 in parentheses. Does that make sense to everybody? Awesome. All right. Again, moving on. Problem for you to try. Again, I want it in slope-intercept form. So kind of work it through, see how you did, and then come back and check your work. Okay, here we go. We've identified the slope. The slope has to be the opposite reciprocal of 5, which is going to be negative 1 over 5. Again, we start with point slope form because it's just the easiest way, I think, to get back to slope-intercept. We had y plus 7 equals negative 1/5 times x minus 4. We now realize we're dealing with fractions all the way through now. We can't get rid of fractions in slope-intercept in linear equations. I know I showed you a way to do that before. In this, we can't get rid of them. We have to keep the fractions because slopes are always going to be fractions. So we work our math out. We distribute the negative 1/5. We end up subtracting 7 from both sides. So our final equation becomes y equals negative 1 over 5x minus, and then it's 6 1/5. You could have done 31/5. Either one's fine. 6.2 if you want to do that. That works as well. For this example here, I'll take that. But just remember, we'll try to keep it in fractions. Try to keep your fractions as an improper fraction. I just did a mixed number here because the math was a little easier for me. Okay, next one. Again, you're going to work through this one. It's the same points as we had before. On the parallel side, we just want a perpendicular line this time. And again, I'm not specifying what type of equation, so you can figure out what to do. All right, so here's the work. Using answers, we figured out our slope again. Slope was 3, so the reciprocal, opposite reciprocal is going to be negative 1 over 3. Again, we had the point they gave us was the y-intercept, so we can just plug that into our equation. And we end up with the line perpendicular to that line as y equals negative 1/3 x plus 10. Does that make sense to everybody? Everybody kind of good? No questions asked? Anything I need to go over, just send me an email if you're not quite sure. And we will wrap it up there. There is homework tonight out on Google Classroom, so definitely check that. And I will talk to everybody through video tomorrow. Have a good day.